Hello, Sharon Sarago here again, and today we're going to talk about triangles. The last video that we had on angles in a plane was very long. This is not going to be nearly as long. I just wanted to be sure that we got settled on the angles because they are so important in everything else that we do. Alright, so let's take a look and see what we've got here. Our triangles are going to be very important on your PSAT and the SAT. You will have them on there. And what we're going to do is cover different kinds of triangles that you are very likely to see on the test. One of them will be an equilateral triangle. Now, an equilateral triangle has all sides equal and it has all angles equal. So, you know, if there are 180 degrees inside your triangle, and if all angles are equal, then each one of them would be 60 degrees. So, you've got this side is equal to this side is equal to this side, and each angle is 60 degrees. So, let's look at another diagram here. We have a square right here, and then we have an equilateral triangle sitting on top of it. And again, all sides are equal. And our question is, what is the perimeter of this whole shape if we know that OP is equal to 9? Well, clearly, a square is going to have 9, 9, 9, 9. And the minute you know that one side of your equilateral triangle is 9, you would know that the other two sides are 9 also. So basically, if you're looking for the perimeter, you just add all those up. Then we have an isosceles triangle. As you know from your past history in school, an isosceles triangle is a triangle that has two sides equal, but not all three of them. And if we have two sides that are equal, the angles opposite those sides are equal. So here's an angle that is opposite this side. Here's the other angle that is opposite that side. And whatever these two angles are, they would be equal to each other. Alright, so down here we have another triangle. And it is looks like an isosceles triangle with another line through here creating some other angles. And our question says, what is y, which would be here, if x is equal to 30 degrees? And they've told us already that SA and AT are the same. Those are equal, so we would want to mark those. And then angle S is 70 degrees. Since it's an isosceles triangle and S is 70, T would also have to be 70. And if you know that, then you can easily figure out what A is. Then you're looking at another triangle. So if this is 140 together, then in order to make 180 degrees, angle A would be 40. And then we've got this triangle. We already know 40 here, 30 here, which is 70. And then we're looking for the rest of that angle. So what would it be? Angle Z would be 110, right? Now let's go back to the question. They want to know what angle Y is. So we're back to our straight line, which I've told you is our best friend because we know it's always 180 degrees. And if we know that angle Z is already 110, then we just take 180, subtract that, and we would find our angle. A scalene triangle is another kind of triangle, and it's one in which no sides are equal in length. And of course, if all sides are different, all angles are different. Then we get to right triangles. A right triangle, remember from our study in angles, is two perpendicular lines, and it is a 90-degree angle. And this little square will always indicate that you're looking at a right triangle and you've got 90 degrees. So we have angle y is 90. Since the triangle is equal to 180, then x plus z would be that extra 90 degrees to make up 100. And let's see what else we have here. Then we have the Pythagorean theorem, which you already know about. With the Pythagorean theorem, we have a right triangle, and remember it says that we've got this formula, a squared plus b squared equals c squared. So if this were a squared, b squared, c squared would always be your hypotenuse. Now, even though you know how to do this, here we've got a right triangle, and we have one side is 6, one side is 8, and if you use that, you would say a squared plus b squared equals c squared. You know, 6 squared would be 36, 8 squared would be 64, and the sum of these two would equal c squared. So these two would equal 100, and the square root of that would of course be 10, so we would know this side was 10. There's another way to do this though, and on the SAT, they hardly ever ask a question where you have to use the Pythagorean theorem. They want to know, what else do you know? So Mr. Pythagoras also made some observations about special right triangles, and one of them was a 30, 60, 90 degree triangle. And what he said was that if you have a 30, 60, 90 degree triangle, you're going to have a certain ratio to it, and it is 1, root 3, and 2. Now let's look at this triangle here. The short side is going to be x. I like to say x rather than 1, 2, and root 3. Short side is x. The hypotenuse is always 2x. And then your long side here would be x root 3. So let's do that again. The short side is always x. The hypotenuse is 2x, 2 times the short leg. And then the long leg is x, which was the short side, x times the square root of 3. Alright, so here we've got an example. We have the hypotenuse, which is 12. If we know that our formula said that that's twice the short side, well then 1/2 of that would have been x, so this would be 6. And if we know that this long side is x times the square root of 3, it would have been 6 for our x times the square root of 3. So if you know this formula, it's very easy to find this. You only need one number to look at it, and you can tell. Of course, you do have to know that you're looking at a 30, 60, 90 degree triangle. But on this test, you want to look for that first. Don't go straight to the Pythagorean theorem, because once you recognize these, it is so much faster to find the answers, because basically they're just in your head. Here's another example. On this one, the short side was 8 root 3. So the y side would be twice that. Let's look at this. Here's your 8 root 3, right? And that was the short side. And so the hypotenuse would be twice that. What I want you to remember is that when you're multiplying times 2, you can only multiply like terms. So you can multiply 2 times 8 and get 16, but you cannot multiply 2 times radical 3. That will not work for you. You can only work with like terms. So then we know that our hypotenuse was 16 root 3, and this was the short side times the square root of 3, x root 3. Do you remember? X, 2x, x root 3. So if we have a radical on our x, excuse me, then you've got 8 root 3 times root 3, which of course is 8 times 3, and that would be 24. Very, very easy to do, but you do have to remember the ratios for these special right triangles. Okay, so then we have an equilateral triangle, and if we take two 30, 60, 90 degree triangles and set them back to back, then what we have is an equilateral triangle. Look at this. Here's our equilateral triangle. All sides equal, all angles equal. But if I drop a line from here, now what do I have? I have right angle here, 90 here, 60 here. That leaves 30 for there. A 30, 60, 90 degree triangle. So we've got, they told us that the perimeter of an equilateral triangle is 24. We've got 3 sides, so divide 24 by 3. We know each side is 8, and they're looking for the height of that triangle. So all we need to do is drop a line down there, recognize that it's a 30, 60, 90, and there we go. We're almost done. You see, here's your line dropping down from the vertex. It breaks up into 2 different triangles here. And so our formula, remember, was x, 2x, x root 3. If this side right here is 8, which is what they said, this side is 8, that means this side has to be half that, which would be 4, and this height would be 4 root 3. Look at this. Here's your short leg, okay? Alrighty. Then we have a 45, 45, 90 degree triangle. This is an isosceles right triangle. We have 2 sides that are equal. Here we go. This side is 1, this side is 2, and they are equal. And then we have 45 in both of those angles. So we have a different kind of ratio for that. It goes side, side, side root 2, or leg, leg, leg root 2. Very easy to remember. So let's see if we can find something that has some numbers for it. We know that if we had a square here and we broke it in 2, we would still have our 45, 45, 90. Do you see that? 45, 45, 90. 2 sides are equal and a right angle there. Okay, so we have a figure here, 45, 45, 90. This is x, and we're looking for the value of x. Do we have something else? Yes, here's the leg, which is 4. This would be 4, and so that would be 4 root 2. How do I know that? Because here's my formula, x, x, x root 2. 4, 4, 4 times the square root of 2. These you must memorize, and as we go through this course, I'm going to ask you to say these for me over and over again. You have to know them. Alright, so let's look at something. We've got a triangle here, a right triangle. Looks like it's an isosceles triangle, 2 sides equal. So we're looking at a 45, 45, 90. And we know that our ratio is x, x, x root 2. So if our hypotenuse is x root 2, then this would have to be 5, right? Okay. You just have to know that formula there. Here's another one. We have a square, and the perimeter of it was 40 root 2. And so that means that each side was 10 root 2. Remember your formula is x, x, x root 2. So if I have to do this, then let's see if I can find the math here for you. We've got 10 root 2, which is our side, 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 side root 2, times radical 2, and that's going to equal 10 times 2. Because if you multiply the square root of 2 times square root of 2, you get the square root of 4, and you know that the perfect square of that is 2. Then we have one other thing that you must memorize, and these are the Pythagorean triples. Again, the College Board very, very rarely is going to give you a question where you get to use the Pythagorean theorem. Everybody knows how to do that. They are looking for students who know something beyond. So it's going to be your special right triangle ratios or the Pythagorean triples. And here they are: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Now, there are an infinite number of these, because anytime that you multiply any of these together, you get another one. So if I multiplied this set by 2, I would have 6, 8, 10. And that's a very common one that they use on the test. If I multiplied it by 3, I would have 9, 12, 15. So any multiples of these are also triples. But you have to memorize this list. And as we get on our meeting, I'll show you a cute little way to memorize them. But I'd rather you start now memorizing them, and then you can just tell me later that you already know them. All right, so let's look at a triangle here. We have, all we know is that it's a right triangle. We have one side that's 9, another side that's 15. They want to know x. When you see numbers, the first thing you want to say to yourselves is this a multiple of one of my Pythagorean triples? Well, yes it is. 3 times 3 is 9. 3 times 5 is 15. And so you're basically looking at a 3, 4, 5 Pythagorean triple multiplied by 3. So this would be 12. And the nice thing is there's really no calculating there. You just simply know that. Okay. And then another example. We're trying to look at the length of y. Oh, this thing was not done correctly. This should have been an x, okay? Here's your y. All right, so we have a triangle here, a right triangle. I've got a 3 and a 4. What comes next? Of course, a 5. And now I have a 5 and a 13. What was the angle that you know about Pythagorean triples? You do not want to try doing the Pythagorean theorem on this. You don't need to, because you know that 5, 12, 13 is one of your triples, and so y would have to be 12. It's just memory work. Well, that's enough about these triangles right now. I'm trying to keep this video short for you since the last one was so incredibly long. Just remember, as you go through your exercises, go back and look at these things and find out what the deals that you have to memorize, work through them, and mark the ones that give you trouble. Because we'll be meeting twice during the week, and you'll have plenty of opportunity to tell me exactly which ones you had trouble with. Even if you happen to get the answer right, I want to know which ones you had trouble with. So enjoy yourself. This geometry is really, really fun. Just smile while you're doing it, and you'll learn to love it. I'll see you at one of our meetings.